If she
Let's just review this guy. So I'm looking at this particular relation. Don't worry about these little dotted lines. The particular relation is this one, and this one. What's the domain? Well, let's see. How do we figure this out? So what I would do is I'd probably label the points. That might make it a little bit easier. So here's 0, 0, right? I go left 2. That means minus 2. And I go down 3. So that one's going to be negative 2, negative 3. Let's see what this one is. I go left 1, and then I go up 5. And this one over here, I go left positive 6, right? And then up a positive 1. So now it's a little bit easier to see maybe what the domain is. What's our domain? How do we get that domain? Right, we're looking at our input values, right? This is an x that's in there. This is an x that's in there. That's an x that's in there. Okay, what about my range? Right, now I'm looking at the y values. So let's see, there was one over here. Let's see, there was one over here, and there was one over here, right? Are those the y values that I'm looking at? Is it okay if these were written in a different order? Okay, could I have written this like this? Whatever order you want. I can change that order. We tend to write it in numeric order. It's okay either way. I'm fine with it either way. Is this a function? Does every input have one and only one output? Sure does. I don't see 6 mapping to anything but 1. Right? Example. Am I right? Now if I had a point here, would it still be a function? No, because then I have a 6 mapping to a negative 2. Then it wouldn't be a function. So if I have one and only one input, I'm good. Get rid of that. Okay. Now I'm using a mapping diagram. Let's start first with, is it a function? Yes, it is. Each 3 only maps to one thing, negative 2. 4, they each only map to one possible output. So there it is. What's the domain? And these are kind of easy, I think. They might be a little bit easier to see even because they put the inputs in one spot and they put the outputs on the other. So what's my range? And again, there's no mapping implied here. I've written it in mapping order, but it doesn't mean that is the mapping. The way I know the mapping is by looking at my diagram. That's how I know the mapping. Okay, excellent. One last one here. This one is just a pure set of inputs of ordered pairs. So first of all, is it a function? No. Okay, why not? Yeah, let's be careful now. The definition is every input, right, has one and only one output. Well, there are 2 nines, but look at the inputs. I'm just looking at the inputs now. So negative 1 maps to 9. Does negative 1 map to anything else? No. So that looks good. 5 maps to 9. Does it map to anything else? No. 2.3 only, right? Does it matter? Do the outputs have to map to one input? Because that's what you're looking at. You're saying, well, 9 maps to negative 1. So it doesn't say that. So you can have the same output applying to different inputs. That's okay to be a function. It means different things if you have something like this. But that's fine. For a function, we're good. So this is a yes. So be real careful about that. That you're only looking at the inputs. You're not worrying so much about the outputs. What's my domain? Make sure you got your curly brackets there.
1, 5, 2, 1, 2, 1.
Those are easy.
9, 7, 8.
Right, we're just reading off inputs. We're reading off outputs. I did put 9 twice, did I? You didn't even say 2. You did? You said 9, 9? You said 9, 7, negative 2. Why don't we have 9, 9, 7, negative 2? Yeah, why not? You only need to tell me one time. I heard you the first time, right? I heard you. 9's an output. Got it. I don't need to hear it again. I know that. Okay? So, great. So when we have a very discrete set of points, a finite set of points, it's pretty easy to figure out what the domain is. function. Non-continuous functions, if I were to graph this, let's see, -1, 9, 5, 9, 2.37, what's going on here, 4, -2, right? They're what we call discrete, separate points. When I drew this function, did I have to lift my pencil to draw that? I did. Now we're going to start looking at something called a continuous function or a continuous relation. I don't lift my pencil. So an example of something that's continuous could just be something like this, a line. I don't lift my pencil when I draw them. That's continuous. So when we look at something like this, we got to really think about it, because can I name every point in the domain? Right here, I can name every point in the domain. I see that. This one, this one, this one, this one. I've named my domain. When I'm looking at this, how many points are on this line? An infinite number of points, right? Wherever you find 2 points, I can always put one in between, can't I? I can get to another point. So can I list every single x value? Can't do it. I don't have that kind of time. I just don't. Even if I did for the rest of my life, I'm going to write down the every single x value. Will I be done by the end of my life?
No.
Is that a good use of my time?
Yes.
Probably not. Probably not. He says yes. So looking at continuous relation, it has an infinite number of points there. I can't just pick out what's my domain, what's my range. We're going to use this idea of inequality symbols to help us describe our domain and our range. We're going to make like a rule about it. First, let's make sure we know our inequality symbols. What's that?
Greater sign, less than.
Less than. Now, how do I know this is less than and not greater than? Something with an alligator. I don't know. Somebody the
Alligator was
listen. See this small little bit? Which I got an A and a B here. The small bit points to the small number. The big opening points to the bigger number.
also
So this is less than. This one. What happens when I do this?
less than or equal to.
Less than or equal to anything. Right, that's what I mean by an inequality symbol. So I'm looking at this example here. You got it right here on your paper there. So now if I say, what's the domain? And it means the same thing I meant before. What is the set of all the inputs? Oh, let me see. I see a point right here. What point is this? And I see a very well defined case right here. What's that point?
4, 4, 2.
And so let's see, what else I got? Well, I got 0, 0. I got 2, 1. I got -2, -1. How long am I going to be here writing out points? A long time. What is that? I think a half. Now, I could be here a very, very long time. So can I say, well, -4, -2, 0, 1, 2, 4. Is that all my domain?
No. You draw a line.
So what I need to, let's describe what the domain is in words first. Domain is I look at all the x values, right? Looking at all the x values. So if I look outside of where I see this kind of line segment here, is there anything going on out here as far as inputs? Do you see any function? I don't see anything. So these x's don't seem to matter. They don't seem to be part of my domain. When do I start seeing x's? Well, what is this thing? -4. Do I still keep seeing stuff? Seeing all kinds of stuff. When I get to 4, and then what happens past 4? There's nothing. Well, look, it's like endpoints. See those endpoints? So in words, what's the domain? Well, it's -4 and 4, right? And everything in between. Isn't that my domain? It's all this stuff right here. This is my highlighters working. This stuff right here. If you go along here, isn't that where I have x's defined?
No. Yes.
I don't know, is it? I don't have anything out here, and I don't have anything out here. So this is the range of values. So in words, I would say the domain is all numbers between and including -4 and 4, and let's get in the habit of kind of putting these in numerical order. So -4 comes before 4. So between -4 and 4. Now how do we say that in math? Well, first let's say questions on where this came from. To me, this is the hard part, is seeing this. Do we see that? Yeah. If we see that, that's awesome, because then the rest is very learnable, very easy. We're going to use what's called a compound inequality. And what does that mean? You see this word compound? You ever hear about the compound sentence in English? What's a compound sentence in English? Oh, yeah, what's a compound sentence? The English class, you guys are good at English, right? You love English, it's not math. What? Wait, I'm sorry, I can't hear Claire. Yeah, and what do you put in between? And. The fire truck is red and the sky is blue. Right? That's a compound sentence. Conjunction. Any conjunction. You can use or, you can use. So we're going to use and, because what's happening here is I want to say that, let's see, well, I know the x's are less than 4, right? Not only is it less than 4, can it be 4? And what else? X is bigger than what? Yeah. Is that true or false? X is less than or equal to 4, and x is bigger than -4. Well, maybe. First, let's see if we can get that little bit of understanding. Does that make sense?
No.
No? Where am I losing it?
Right there.
Where?
Yeah.
Is x less than or equal to 4? Right there's 4. Right? Is this where my x's are? Now when do I stop? X has to be bigger than -4. Doesn't that kind of bound it?
Oh, I got you.
So what we're going to do now is use this idea of a compound statement, a compound inequality of n. So I'm going to turn around this guy. If I put the x here and the -4 here, what happens to this? Because again, right, the big piece, the x is the bigger part, so I still need the big piece pointing towards the x. So let me write them a little bit closer together. So -4 less than or equal to x, and x is less than or equal to 4. I'm just going to kind of join these together. And this is a compound inequality statement. It says -4 is less than or equal to x, which is less than or equal to 4. It's how we write x is between, and in this case includes, -4 and 4. So think about that for a moment. If you cover up this bit, can you see how x is less than or equal to 4?
Yeah.
If you cover up this bit, you have to think about it a little bit more. But isn't x bigger than or equal to 4? If you read it backwards, who knows how to read right to left? There's something to do with languages, right? X bigger than or equal to -4. So that is how we write these English words. This is how we write it. What do you guys think?
Good.
No?
Short and less than
What? Well, no. Well, we're just learning how to write the inequality statements, okay? So we got that. A question about that. To me, this is the hardest part of the whole thing. Yes. Okay, where did I lose you? Are we okay with this bit up here? Right? Can we see why x is less than 4 and x is bigger than -4? Because if here's 4, I'm less than that, but I'm bigger than this. So I basically want to say x is between the two values. In this case, I'm also including the endpoints. And this is how we do it. That's how we write that. We always use the less than equal or less than for these, because we always put the smaller number on the left and the bigger number on the right. We kind of write them like numerical order. So you're never going to see this statement with greater than. If you have a compound statement, you're not going to have greater than. It's always going to look a lot like this. That's how you say a number is between the values. That's what we're saying. Good numbers between the values. Yes, ma'am. Yeah. Well, what are we going to do with range? Let's go with a little bit more highlighting. Now, range is y values, right? So now instead of going this way, I'm going this way. Where do I see the function starting on the y-axis? Now, if I start down here, I don't see anything. I see nothing until I get here. I see stuff. I see stuff. It's stopping. So what are my y values? What are those y values going to be? Nothing, nothing, nothing until I get to the y of 2. Stuff, 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 until I get to a y value of 2. So y is that it includes those values as well.
So the exact same thing.
Well, it's a very similar format, except I'm going to put a y here. Y is between what two numbers? -2 and 2. You put the smaller number here, the bigger number here, right? Because that's just what we do. It's between them, so I'm putting less thans. And now I have to determine, am I including -2 and 2? Here it is, -2. Yeah, they're in it. So you make them equals. So y is between and includes -2 and 2. So and this is the hardest part of the whole thing, right? Can you see that the x's go here, and can you see that the y's go here? If you can see that, the rest will be fine. It'll be fine. Is it a function? Yes. Let's go back to that. One, yes or no?
Yeah.
Yes. Every input has one and only one output. We're getting really good at that. Questions about this? Okay, let's try a different one. Wait, what? Yes! Maybe. Yes. That's what I'm going to answer from now on. If the question begins is, if on the test, I'm going to say yes. Don't worry about the test so much. Just stay with me right now. The test takes care of itself if you stay with me right now. Okay, so let's start with the function question first. Is this a function? What's your question?
So all you have to do is basically just put two numbers again, a y or next to the middle, and then just put a
So that's sense. Yeah. For a compound statement, that's pretty much it. All right, but let's see. Let's look at this particular thing. It's a function, right?
Why is there circle one?
Well, that's my question. I see a closed thing here. Let me remind you, do you remember doing this? Y is less than or equal to 1, and they gave me a number line. Do you remember how you graph that?
Yes.
No. All right, so remember, you go to 1. Oh, wait, here's
Yes. If the line at the bottom says 10, color in the circle.
all right, but listen to me. I love Miss Bear. I do. Miss Bear, if you're listening to this, I do adore you. We're going up to algebra 1 now. Big boy, big girl math. Let's think about what this says. Y is, first of all, it's less than it. I circle it, right?
Yeah.
So y less than 1 goes in what direction? All the y's that are less than 1 are over here.
Yeah.
But can it be 1?
Yeah.
This is like a hole. This is a black hole. You can fall right in. But this says, it can be equal 1. So we put a manhole over it. See, I got my own little things I can say. We color in that hole. We fill in the hole. Because y can be 1, and it can also be smaller than 1. So what do you think this means? That this one's filled in, and this one isn't? Yes.
You have to include the one that's filled in, but you not include the one that's not filled in.
Oh, virtual gold star. Absolutely right. This one, if you go to graph 2, 4, you know what's going to happen? It's a hole right there. You're going to fall into a black hole. You're gone. It's not part of the graph. If you go to graph -2, 4, I should write these points down. The manhole cover, I can graph that. There's no hole there. It's fine. So it's telling us a little bit something about our function. So let's think about the domain. Let's go back with this here. So my domain, what is this called? So I'm going left, right? Nothing. When do I start seeing stuff?
And go down for infinity.
Nothing. See, I'm just looking for stuff. So what is my domain? And in words. Don't worry about the less than, whatever. In words. What is my domain? What is it? -2 to 2. Do I include -2 and 2? Think about it, Andrew. Let me hear what you've got to say. Whoa! What? Think about that. Why am I including -2? It's filled in hole. I can include that. 2, it's an open hole. I drop right through the graph. Absolutely right. So that's it in words. That's 90% of the battle. Now let's think about how do we write that. So I got my x, right? So what's my point on the left? Well, I'm going to have Andrew help me with this one. I'm letting Andrew help me with this. All right, so, all right, I put my small value here, my big value there. What comes next?
You have the less than sign right there, and the less than sign on every side.
Okay.
You put the line under that one, not the other.
Look at that. Whoa. Wow. Beauty. Think about it. But what is it? What is it?
I just had a question.
Yes.
So if there's like the hole is open, then you don't put the line under it.
Because it's not equal to, because what happens if you graph this?
You'll fall
You fall through the hole. It does not include them. So you're going to be really careful with that. What are real numbers? What are real numbers?
1, 2, 3, 4, 5.
Well, real numbers can be fractions and decimals.
All real numbers.
But what are real numbers?
From 0 and above.
They're rational, they're irrational. You have to know what that means, right? So they're numbers we can write as fractions. They're numbers we can write as decimals. They're numbers that are irrational. Like he says, the square root of 2 is an irrational number. Square root of 3. You can write them as a decimal. Square root of 3, 1.732. I can keep going forever. They don't repeat a pattern.
Like pi.
So yeah, like pi. So it's everything, all the real numbers that we know about. So we want to include them all, including 1.991. So that's part of this, just not 2. So how about range now? Let's look at range. So range now, I'm traveling. I'm on the y-axis now, right? Nothing. Oh look, something. No, it didn't make, wait, okay, so we're going. I see stuff, I'm stopping seeing stuff. So what is my range? In words, don't worry so much about the equality. In words.
Range, it is between 0 and 4.
Do I include 0 and 4?
Yes, because we're not on this.
Right, 0, 0, that's on the graph, right? What about 4?
Or yes, and it's not on the
Well, I got a hole over here, but look over here. So I include it because it's okay on this point. So those are the words. The words are between and include. 0 and 4. How do I write that? Or, okay, wait. Yeah, go ahead. Well, first I'm going with y, right?
Yeah.
What's your smaller number between 0 and 4? Okay, less than equal to for both? No. Why not?
Because the hole is open. So
Yeah, but now I'm looking here, right? So you're right, it's open here, but look on this side. Closed.
yes.
So it is part of the range. Wow. Yeah.
Aren't we supposed to put a seal thing like that?
We're not there yet. You're right. She's so right. We're going to worry. There's a little bit extra we get to do with these squiggles. So I'm leaving them off for now. Because to me, you know why? This is the hardest part. If you can do these squiggles are going to get so easy. But these are a little bit tricky. All right, let's look at the next one. Wait. Let's think about this one now. So, okay, I'm looking for example. First, open a function.
Yes.
Well, they're not always functions, but we're just looking at some function examples. So, I'm traveling along here. I'm on my x-axis. I don't see a thing. Oops, now I do. All kinds of stuff here. Oops, how long am I going to be going?
Keep walking.
Right? Well, how do I know I'm keeping going forever? See this arrow?
Yeah.
So you've got a picture, and sometimes that's hard to do. But this thing, forever and ever and ever, eternity, is going in that direction. So in words, what are valid inputs to this? What's the domain? What's in words?
The domain is 0
And bigger.
yeah.
0 and bigger. How do you say 0 and bigger using an inequality? How do you say it? X is greater than or equal to 0. Isn't that how you say it? Well, what about the other thing? When you said the less than, and you said, is this bounded by 2 points this time?
No.
It's between 0 and infinity. What was Buzz Lightyear saying?
To infinity and
Yeah,
beyond.
that's what we're doing. So, then what's the domain? X is bigger than or equal to 0.
And then the range.
I'm waiting.
Does it matter because there's no
What do you think? Do you ever say this? Can we talk like this?
No.
Put your X like this. Right? You're discussing what is X? X is bigger than or equal to 0. You don't say 0 less than. You just don't talk that way. So well, this is a compound statement. This is different. Right? So I want you guys to keep the brains on tight. Try to do less of what memorize exactly what she says. And do more about thinking. forever to infinity and beyond. Right? How do I write? It's 1 and bigger. Y? It's Y, right? Y what?
Is greater equal to or greater than 1.
Wow! That one's so easy. And it's easy if you see it. It's like one of these things you're going to have to think about it a little bit. Because it's like, what? You have to think about it. It's one of those things that it tends to click. Just like nothing, until I get to 1. And then it keeps going forever bigger. So Y is 1 and bigger. Sometimes we get confused between the X and the Y. If you need to kind of draw these first, do it. You know, so whatever makes you visually see that first. Oh my goodness. Questions? No. Yes.
All of that
Well, give me a question. Where did I confuse you? Where did I lose you? Because you're looking 2 directions. This is the X direction. This is the Y direction. Right?
but where did it start?
Well, that's the question. It could be anywhere along the along this axis, right? So I'm looking for my line. I don't see a thing until I get here.
Yeah.
And if I'm going the other direction, I don't see a thing until I get here. So let's try this last one. Oh my goodness, look at this thing. Is this thing a function?
Yes.
Look at it. There, yeah, something going wrong. I have to go find one that isn't a function. Just for you. Okay. Now this one, let's see. Domain. Let's be careful and think about this. This goes forever, right? These 2 things. You got to picture this, and it ever widens, right? You have to in your mind, and it's hard to do this. Can you picture infinity? Like what happens to this particular function at an infinite value? How far apart is it going to get? It is going to get, it's going to be the entire x-axis. What can I use as an input into this function? Now I can see why, oh yes, I can use 1, and I can use -1. I can even see why I can use 2. What if I'm out here at 10? And I go down, am I eventually going to hit this function?
No.
What if I'm out at 1,000,000? If I go down far enough, am I eventually going to hit this function?
Eventually, yeah.
So what are my valid inputs into the function? Any number. Any number you want. What about the negatives? Can I go negative 1,000,000?
No, wait, what does that mean? Yes, because it's going that same direction but the other way.
That's right. So if you were to try to picture what was going on here at infinity, that's a hard thing to do. You really are covering the entire x-axis. It's a freaky thing. You got to think about it. So what are my valid inputs? Anything you like. Yes?
So if both sides on the arrow that we made goes down.
Yeah. This means it's going forever. And look how it's ever widening.
How do we know that it's not going to
Well, we can't. But that's what this means. If it was going to turn, they would have to show us this, or they'd have to say what interval we're talking about. So we have to just trust it when it's saying this that it's going forever, unless they tell us different. Okay, what about the range though? Because I should really try this guy.
X is
Right,
Y is less than or equal to 2.
Well, let's see what's going on here. I'm going to start from the top here. I see nothing. Whoa! Bingo. How far down is this going to go? Forever. So let's think about what's going on with Y. There's definitely a Y too. Can I be bigger? Can I be smaller? So how do I say Y is 2 and everything's smaller? How do I say that?
Y is less than versus less than or equal to 2.
Oh, got it. That's what you were shouting out. He raised his hand like a proper student. Okay. What do you guys think? Yes, ma'am?
I don't really get it.
Ask me a question. I'm going to help you. I want you to get this.
I don't really know how to get domain and range.
Domain is what can I possibly put in as an x value? Right? Can I use 1 as an x value?
No. Yeah.
Yes. Can I use -1?
No.
Can I use 5?
No.
Well, because you got to picture this continuing forever and ever. So 5, what's going to happen? I'm going to be down here.
No.
Then yes?
Yes.
So then there is function. Function is, can you see the line? Right? Can you see the line? If you're at 10, will I eventually be able to find the line again? Yeah. If I go to negative 10, will I eventually be able to find the line again? Yeah. So, what are possible inputs? If I go to 100, will I eventually find the line? What are my valid x values? Anything.
Like
Anything.
I don't really get. I get that, but I don't get the ones that not the arrows.
The boundaries. We're going to go over that again. Yes.
How come this y is less than or equal to? It's not.
Well, because can it be bigger than 2? Do you see anything? I don't see anything. So I'm only going to look for where is the function defined, and it only seems to be defined at 2 or less. Yeah. Oh, where's it start? Up to you. Okay. So that if we get that, this next bit only looks hard, but is it hard? No, it isn't. This? No. Well, now, who was that? That was Katie, right? Don't you need the little set things? Wasn't that you? That was her. She's absolutely right. A domain and a range, their definition is that they're sets. And sets have to be inside the curly brackets. So we're going to learn about set builder notation and how we put this information so that we get a set as the result, because we want a set. I want the set of whole numbers, that is the domain of a particular function or relation. So we're going to use this thing called set notation. So here are my curly brackets, because it's a set, so I have to have that. Now I can't explicitly say, in one like this, can I explicitly name every single point that's in the domain? Can anybody say every number, all the real numbers? No. Okay, so we can't do that. Even this range. This isn't all the real numbers, it's only those that are less than or equal to 2. Can I name all those? Can I name all the numbers between 2 points? Can I name all the real numbers? I can? What are the real numbers between -2 and 2? 1, 1. Yeah, well, that's one of them. So can I name every single? Can I name every single real number? Not just integers. I can name the integers. You're right. But I'm not just working with the integers. I'm working with the fractions and the decimals and all the things in between. So we're going to use these conditions that we've been practicing writing. So we put them in these curly brackets, and this is how you read them. The first thing you're going to do is you have to say, well, what kind of a number is the x or whatever variable that you're talking about? What are we talking about? And we're using real number subset. That's a little late. Okay, this is the symbol for real numbers. Real numbers are numbers that we can write as fractions. They're numbers that are decimals that don't repeat but continue forever. They're integers. They're the numbers that you all know. Any number you guys can probably think of are real numbers. We have other numbers that are subsets of these, right? Yeah. I don't know if you've seen this before. We used to teach this in pre-algebra. This is the symbol for integers, believe it or not. And what's an integer? An integer, it's a number that we don't write as a fraction, right? It's divided. What is it? Any what? Whole numbers, negative numbers, right? Right. So 1, 2, 3, 0, -5, -10, but nothing with a fraction or decimal piece to it. So we have all our different subsets of a real number. So the integers are real numbers, but not all real numbers are integers. So we have to kind of say, well, what are we working with? Now, in our situation, we're always going to work with the whole set of real numbers. So it makes it a little bit easier. So first we say x is a real number. Now this little bar, we read that as the words such that. Such that. So x is a real number such that, and then we have a condition. That x that you picked has to be bigger than 3. So if the x that you pick is bigger than 3, then it goes in a set. So let's say we're trying to build a set based on this rule. So pick a real number. Pick any real number. 5. 23. We're going to go with 5. 5 is a real number, yes. Such that, is 5 bigger than 3? Yes. Then 5 can be in my set that I'm describing. Pick a negative real number. Negative 8. So x is a real number, right? Such that, well, is -1 bigger than 3? No. But I'm not going to put it in the set. Okay, pick another 0. zero. How about zero? Zero's a real number. Zero bigger than no. So what numbers are going to wind up in here? All the numbers bigger than 3. So it's a way of describing, instead of writing them all, what numbers I'm talking about. So this is, what kind of number is it? And this little symbol looks like an E. It means it's an element of the real numbers. X is an element of the real numbers. These are the X's you're allowed to choose, and they are bigger than 3. Those are the numbers I'm talking about. That's what set builder notation is trying to tell you. We have a special case that we have to think about. So the last one, I think, we had all real numbers as the domain. Anything would work. Am I right? Did we have that all real numbers? Yeah, it's over here. Yeah. Where is that? Right? Any number you want. So how do you write that in set builder notation? So you make your curly brackets, and you say, okay, it's a domain. I'm working with X. X is an element of the real numbers such that, now what rule do I want? So any real number you pick, what's the condition to make it all real numbers? It's not less than 2. I want all the real numbers. No. I want all the numbers. So let's think about this. This says pick a number in a real number system. Do I want it in my set? Yes. Because I want all the real numbers. So this is a way of writing a set that says all real numbers. Okay, now the reason we need this is because sometimes maybe I only want integers. So I would say X is a Z such that, I don't know, some condition. So I can only now choose from the set of integers when I'm building this set. That's why we kind of have these distinctions, because this eliminates a whole bunch of numbers, right? Anything with like fractional pieces or decimals, I'm only choosing from a certain set of numbers. So for our purposes, we're not doing that. We're only worrying about these real numbers. So you don't have to worry about that for us. But eventually, when you get into a little bit more higher math, you're going to see stuff like this. So I just want you to know what it means. Now this little piece here, let me write one a little more typical. We've got that one up there. This is the set of all real numbers bigger than 3. That's what that says. This piece here is the default. It's the default number set that we're using. So what does that mean? It means that if I saw this, which is almost the same thing as that, right? What's different? I took this out. I'm just saying you have an X, and I'm not saying what kind of number it is. If you don't say what kind of number it is, we're going to assume you mean real number. So you don't have to have that here when you're writing. But I would rather kind of look at some examples first before we kind of think about that a little bit more. One other thing to note, if there's nothing in your set, there's a couple of ways to say that. You can say just a pair of empty brackets, that means it's an empty set. Or we can use this little null symbol, it means that that's an empty set as well. We're not using this very much, but I just want you to have seen it. We're using stuff like this. Yes? It means it's an element of the real numbers. It's set notation here is an element of. So X is an element of the real numbers such that X is bigger than 3. That's defining my rule, my set. Yes? Let me show you how we're going to use this. So I kind of have the same example. So if you go to the same paper that we've been looking at, if you look on the back, see I've lost my paper. I kind of have, these were the domains and ranges we came up with. And let's just make sure we still understand that, right? So remember how domain works. Right, this is domain. Where do I see stuff for the X's? And then this is the range. Where do I see stuff for the Y's? So before, we said, well, the domain is -4, less than equal to X, less than 4. Do we still remember why that's true? Why that's our domain? What are my valid inputs? Everything and including, everything between and also including the ends, -4 to 4. So what we're going to do now is, because Katie points out that these are sets, I have to put them in curly brackets. That's number 1. That tells me it's a set. But I have to tell people too, what do you mean by x? What's x? Is it an integer? Is it a whole number? Is it a natural number? What is x? You have to tell us. X is a real number such that this condition holds true. So now I'm telling you what x is. Now I'm in set builder notation. This is what I'm using it for. Because now I can describe an infinite number of points without having to write them all down. Because I can't. So that's what I'm using it for. Now the range for this, do we remember y is between and includes -2 and 2? Right, my range. So you basically, this, like I told you, this is the hard part. Coming up with the condition. To write something in set builder notation is very, very simple. Put in the curly brackets. Declare your variable. I've got a y here. Well, what kind of number is y? Y, for our purposes, is always going to be a real number. And then this little line means such that y is between and includes -2 and 2. So we're just being very thorough in defining our set and what it is we're actually looking at. I don't have to write every single point anymore. There it is. Yeah.
So only
Yeah. So we're going to go through every single one of them, okay? So yes, we will. So this is the first one. When we go to the second one, we reviewed this one, right? Let's review it again with this with our finger. Right? The domain is between -2 and 2. Well, why is that? Well, let's see. Because here's where I see stuff for the x's. And then where do I see stuff for the y's? Well, I see it from here to here. So write the inequality first. Don't worry so much about the set builder right away. So I'm between and including on one side, right, the -2, but I'm less than 2. I'm not including it, though, because I have that open circle, that hole right there. So do we agree, again, just as a review, do we see why that domain is this expression over here, or this inequality? Okay, now let's turn it into set builder notation because it is a set. So what do I do? First, put in your curly brackets, and then declare your x. X is a real number, such that. Okay, my range, those are numbers between and including 0 and 4. So that's how I write the inequality. Again, I think that's the hard part, is kind of seeing what the inequality is. And then, make it set builder notation. Y is a real number such that this condition comes true. And that's how I define what all the numbers are between 0 and 4. I want all the real numbers, right? Not just the integers. Now I'm telling you that very explicitly, what I want. Okay, so what I was talking about before, being a real number is a default value. I could have written the domain this way. Oops. And I could have written the range this way. What's different between what I did here and what I did here? I don't have is an element of the real numbers, because if you leave that out, I am assuming that's what you need. So it just got even a little bit easier to write these. All you have to do is put the curly brackets in, declare your variable, put your line headings such that, and there you go. I'm in set builder notation. So again, the set builder notation looks hard, but it's not the hard part. The hard part for me is just figuring out this part. Can you put in my basket if you're done with it? What? You can. You can. You can absolutely put it here. And it's not an ER. It's an element of the real numbers. You can do this. It's fine. But you don't have to. You can or you can't. Now, most people choose not to. It's less to write. I don't blame you. I would too. But I need you to understand what it is, because you're not always writing it, you're reading it. I may give you a domain, or I may give you a range. You have to be able to read that and understand what it means. So that's why we're kind of switching both ways. Any questions about that? Okay, let's just review the other two that we did. So this is the one where the domain, right? I don't see stuff till I'm here, and then it kind of keeps going. And then my range, I didn't see anything till I got to 1. And then it kept going that way. So let's see here. This x says x bigger than equal to 0. That's my domain. Well, how do I turn that into set builder notation? Curly brackets, declare your x. I'm stopping here. Could you put x as an element of the real numbers? Yes? Totally to you if you want to do that or not. Okay? The range for this one was y bigger than or equal to 1. Does anybody kind of need that re-explained? This one was a little bit tougher for some people to see. Yeah? Right? Okay, so we look at our y values. So now I'm going up and down, right? That's where y lives. And I'm starting here, I don't see a thing but the function. See when I get to 1? There's a range value there. And as I get bigger, I can see that there are range values here. There's a range value here, here, right? If I keep going, I'm going to see one out here because that line keeps going. So when I get to 1 and bigger, I start having range values. So my range goes from 1 and bigger, which is why y is greater than or equal to 1. Right? Again, that's the hard part. Now what's the easy part? It's a set. So put in your curly brackets, declare your variable and the line that's saying, you know, my variable's on the left and my condition's on the right.
You don't have to write the,
No, you don't have to. However, if I gave you, I said, here's a domain. You have to know what it's talking about. Right? So you have to be able to read it as well as write it. You can write it if you want to. But either way. What else? What's the last one here? Because I got a question on the last one, which is our domain here was all real numbers, right? Because when we look at this, right, it's both directions here because this keeps going forever and ever. And then our range was 2 and down. So all real numbers is how we say the domain in English. So let's remind ourselves how we say that. I want x that's a real number, and x will be in the set. Because I'm not putting a condition on that real number. I want it. So this says any x you pick, put it in the set. Any x that's a real number, stick it in the set. That's how we say that. Now the y values, our range was y is less than or equal to 2. It has a condition because we're not using all the real numbers. So I put my brackets in, declare my y, I separate my variable declaration from my condition, and there it is. Questions? Yes?
did you go to the one before?
Can I go to the one before I can? What's your question?
So for the 0, all you have to do is just put the y actually 1.
I don't have to. This is what we call the default. Right? X is a real number. If I don't say that, that's what I'm going to assume. X is a real number unless you tell me differently. So you can say it or not say it. It's both correct. Other questions? So when you think about it, this part is, you've never seen it before. This whole notation, is it that bad? Not really that bad. Kind of figuring out some of this stuff is a little bit hard. At least at first, it's one of those things that you're like, oh, you're suddenly going to get it, it's going to click. So I have some new tries here that I want you to try. Let's just do one together, just to kind of start with fresh, all the pieces. So I'm looking here. Let's see if we can figure out the domain. And I kind of like to just kind of scan along here. So I'm starting on the left here. Do you see any function so far? I don't see anything. Oh, okay, I see stuff. I still see stuff. I don't see stuff anymore. So that's my domain, right? And then you're right. Is it a function? Is it not a function? Yes, it is a function. All right. But what's my domain? And just do the inequality first. Don't worry about the step build or notation until you're done. So what's the inequality? Let's do it in words. It's -3, but am I including -3? Well, got a hole here, right? So I don't, -3 is not on this graph. There's a hole at -3. But I don't include it. But then I go to 3. Do I include 3? No. So it's between -3 and 3, including 3. So how do I write that as an inequality for my x's? You want to try it, maybe? Well, what are my boundary points? Right? I see one here. I see one here. Yeah. So let's put the low number on the left, the big number on the right. We always do that. Where? Well, let's look at the -3. Is -3 on this graph? No, it's a hole, right? That's the hole, if you try and graph it, you'll fall right in. So this one's just going to be a less than. If there's a hole. Now what about on this side? Let's look at the 3. Yes. Okay. But now, oh, curly brackets, you're the one who reminded me. So how do I write this in set builder notation? Curly brackets. That's it. That's it. Okay, you got enough there. I'll be following along your shot. Yes?
Why is it -3 and 3 not -5?
Because it's -5. And I'm doing the x's now, right? Domain, do you see anything going on here at -5?
No.
Do you see anything going on here? When do I start seeing stuff?
Oh, there.
At -3. And I still see all kinds of stuff here, then it stops. Okay, now let's think about the range. Okay. So I'm coming along, I don't see a thing until I get where? -3. Going up and going up, I still see stuff. Oops, I don't see anything once I get past there. So let's see, what are my boundary marks here? If -3 and 3, there is a y here. Think carefully, don't be automatic. Who's closed, who's open? Okay, when I'm at -3, now I'm looking at y's. So what's happening? That one's the closed one, so he could be an equal. And as I work my way up, I get to the 3 here. Am I going to have a y at 3? I can't have that, so that was just the less than. So it looks like, oh, that's the same thing. But you kind of have to turn your head around. Once I'm looking horizontal, and once I'm looking from the vertical. Okay, this is the hard part. What's the easy part? Set builder notation, right? Put in your curly brackets, declare your y, it's in set builder notation. Well, it's kind of something you just gotta get used to seeing it. You've never seen it before. Alright? Do you think you guys can try the next one? Now, just for laughs here, is this one a function? No. Go ahead and see if you can figure out the domain, figure out the range. Did we get C? Now, are people still working on it? If you think you have it, I do have the answer. Well, yes, I got it. Oh my gosh, there's B. I forgot to put B. There's B. C. And how do I get this? Look, if you just kind of think about, and you can draw them, you can put these lines on your paper, guys. So, I don't see a thing until I get to -8. And then when does it stop? At 6. 6 is an open circle, a hole. So -8, including -8, and 6, not including 6. That's what this says. Then when I look at the range, well, where do I see stuff? Between -8 and 6, not including -8, because that's where my hole is, and then not a hole there. So that's why this is a less than, and this is a less than equal. What? Well, you gotta think about it though. Yeah, it doesn't, I could have shifted this over, it wouldn't look like that anymore. What do you think? Last one. Is it a function?
Yes.
No. No.
Yes.
It is. What's the domain? In words.
X.
Just in words. What's the domain?
Anything.
All real numbers, right? I can be anything. How do I write that in set builder notation? X such that X is in the set. X is a real number, put X in the set. What about my range? Think about what's going on here. I don't see a thing until I get here. And then look at those arrows. So you got to think about this continuing in all directions. How do I write what the range is now? Story. Well, greater than puts me up here. Less than puts me down here. Right? Don't, isn't it less than 4? Look at the numbers.
Yeah, it would be less than 8.
Is it?
Yeah.
And 4, is 4 part of this? Yes. So that hard part is only not equal to the number. If there was a hole here, then it would be not equal. Well, and a lot of this whole thing was a hole.
Yeah.
But you know, we don't know what the whole thing is. It's a bad example. We show what a hole would be. So, and then make it set builder notation. Should be getting easier, right? What do we think? We can do this.